This is a video from section 3.10, fy equals f of x, where f is a differentiable function. The differential dx is an independent variable, which means it can take on any value it chooses. The differential dy is then defined in terms of dx by the equation dy is f prime of x dx. And so the purpose of this video is to look at examples where we compute dy. So let's go ahead and do that. Suppose I ask you to find the differential of the function. And so let's take a look at example 1. Suppose I had y equals e to the 5x. And you're going to see this notation again when you hit chapter 5. So this is notation that we do need to get used to. So if I want dy, basically what I'm going to do is I'm going to take the derivative of that function and attach a dx to it. And so this is going to be 5e to the 5x, remember chain rule, times dx. That dx absolutely has to be there. So you're looking for what's called a differential. So let's do example 2. Suppose I had y equals square root of 1 minus t to the 5th. It doesn't always have to be an x. So notice here y is a function of t, but I still want dy. Now, if it helps, you want to write this as 1 minus t to the 5th to the half, okay? And so I got to apply the chain rule. So I'm going to take 1/2 times 1 minus t to the 5th to the negative 1/2. But by the chain rule, I have to multiply by negative 5t to the 4th. That's the derivative of the inside function. And so, and by the way, what I forget, we have to put a dt on the end of that because we're computing a differential. So dy, and so no negative exponents. So we get negative 5t to the 4th divided by 2 square root of 1 minus t to the 5th, right? And this is dt. So that would be the differential. Let's take a look at example 3. So for example 3, suppose I had this. Suppose I had y equals theta squared sine 2 theta. And I want dy. So we have to apply the product rule. So I'm going to take the derivative of the first function, which is 2 theta, and I'm going to multiply by sine 2 theta plus theta squared, the first function, times the derivative of the second function, which is 2 cosine 2 theta. And then this whole thing, I have to attach a d theta to. So it would look like that. Because remember, y is a function of theta, and we're computing a differential. So dy is 2 theta sine theta plus 2 theta squared cosine 2 theta d theta. That's example 3. And let's do example 4. So in this example, we have y equals square root of 1 plus cosine theta, which again I would recommend maybe writing it as 1 plus cosine theta to the half until you get a little more used to it. So if I want dy, this is 1/2 times 1 plus cosine theta to the negative 1/2. But remember, I have to multiply by the derivative of the inside function, which is negative sine theta. And since you're finding a differential, I have to attach d theta to the end of that. And so dy is negative sine theta. If I were to simplify, and I'm going to divide by 2 square root of 1 plus cosine theta d theta. So that's example 4. Now, so suppose I said this. Find the differential dy. So that'll be part A. Part B, suppose I said evaluate dy for the given values of x and dx. Delta x and dx are the same thing, by the way. Now, let's take a look at, we'll call this example 5. So suppose I had y equals e to the x over 10, and x is 0, and dx is 0.1. Now, remember that dy is the derivative of e to the x over 10, which is e to the x over 10, but by the chain rule, I have to multiply by 1/10, and then I attach that dx there. Now, that's part A, by the way. So that's the differential dy. For part B, for x equals 0 and dx equals 0.1, we can compute dy. dy will be 1/10 e to basically the 0, right, times 0.1, which is, now what you can do is make 1/10 0.1, and so this will be 0.01. So I'm going to put dy as a decimal. Notice that dx is a decimal, so I'm going to leave dy as a decimal as well. So that's kind of my rationale there. But in a nutshell, you're just taking it one extra step. So if we take a look at example 6, suppose I had y equals cosine pi x, and x is 1/2, and dx is negative 0.02. Yeah, okay. Now, for part A, let's do dy. So dy is negative pi sine pi x. But remember, it's a differential, so you have to attach the dx. Okay? Now, for part B, now for x equal 1/2 and y equal negative 0.02, dy, so this is really just an exercise in plugging these values in, and by the way, that should say dx right here. it's just an exercise in plugging these values in. So you should get negative pi sine. Now I'm going to replace x with a half. So it's pi over 2. And I'm going to take that and then I'm going to multiply it by negative 0.02. But remember that sine of pi over 2 is 1, right? And so this is going to be 0.02 pi. So that's what my dy would be. And again, this is one of those, you have a fraction and you have a decimal. You may want to double check with your instructor, but you would either write dy as 0.02 pi or dy is, let's see, that would be 2 over 100, which is 1 over 50 pi. And I would think either one would be acceptable, but again, this is all dependent on your instructor and what that person prefers. So I would again suggest double checking. So we're going to do one more example for this video. Now, suppose y equals, we'll do this one. Okay, so y equals x plus 1 over x minus 1. And x equals 2 and dx is 0.05. So dy, we're going to take the bottom function, which is x minus 1, times the derivative of the top function, which is 1. We're going to subtract the top function times the derivative of the bottom function, which is 1, and we're going to divide by the bottom function squared. But again, don't forget, you got to attach that dx there. We're computing a differential. And so dy is x minus 1 minus x plus 1 divided by x minus 1 squared dx. And so therefore, dy is negative 2 over x minus 1 squared dx. So notice how the x's cancel, and negative 1 minus 1 is negative 2. So this is part A. Now, for x equal 2 and dx equal 0.05, dy is, so we're going to take negative 2 over 2 minus 1 squared, and then I'm going to replace dx with 0.05. And so dy is negative 2 times 0.05. But 2 times 5 is 10, right? So you get negative 10, but it'll be negative 0.10. And so that'll conclude this video for section 3.10. This is on the differential where we did 7 examples. And, you know, before we wrap up, you may want to write it this way. dy is negative 0.1. So that would be correct for this example. Okay. All right. Thank you.